Welcome everyone to this channel of AI Hands-On. In this weekend project, we will be doing a small project to detect a fish death or ill fishes in an aquarium. As an aquarium enthusiast myself, I found many a times that the fish often dies or just became ill. And when they became ill, the majority of the time slows down before going into an irreversible damage. So I thought, why not produce an vision related project to detect this ill or slows down fish so that they can be detected early on and it can be used to treat the fishes well before time before they dies. So hang on with me to see how we do it. So these are the steps which I am going to follow. First, I will tell you about the idea. Then I started data collecting. So for that, I took a lot of images from my mobile phone of my aquarium, as you can see here. And majority of the images I took are around the frame of from the front as well as from the side. I tried to take a lot of things into account, like different lighting in the daytime as well as in the evening and in the night, with the lights on and lights off, so that I get a variety of lighting as well as frames. Many a times I tried to take some of the close-ups also and some of the far visions, so that it can detect if the condition changes later on. After the data collection is done, I started my data labeling process. For data labeling, I used a label studio, and as you can see, I have labeled majority of data by hand. So as you can see in this image, I have labeled three fishes here, and I kept on doing that for a long period of time. It was a very tedious process, but in the end, the result was very grateful. So I didn't mind. Once that is done, I started doing many of the augmentation about the images. As you can see, I augmented the images in my data set. Yeah. So I augmented my images with a lot of things like this blank areas where which can be helpful to increase the accuracy, and then various crops, various zooms, various focuses, and various kinds of lighting. And this is the side view. So I took all the images and then augmented them, as simple as that. Once that is done, I went to the next step. And what is the next step? The next step is training the Yolo model. So for training the Yolo model, as you can see, I have used the GPU and did my training on 250 epochs with this data set. I prepared the data set, used the YOLO VN model, and then trained it for the 250 epochs. The training took a lot of time on my PC, so I stopped it and then used Colab to train the images. It took around 2 hours to train all these images, and the results were pretty much good. As you can see, even on my PC, it reached around 0.91 MAP50, which was pretty impressive. But I could not get some of the results as I expected while testing it, so I trained it for a little bit more epochs for around 300, 350, and then my results were satisfactory. Then I inserted my images into the dataset and found out that whether it is working or not. As you can see, I have tested some of them. I will show it to you. Yeah, here. As you can see, this is the single detection image. So this is the reflection of the image. It is able to detect a majority of times, and it has a very troublesome time. Although I took a lot of efforts not to label the reflections in the tank, but it was a problem till the end. So the only thing I found which might be helpful is to take a frame in which the reflections are minimized or they are skewed enough to differentiate between a real fish and an abnormal fish. So as you can see, it is able to detect it and give me a pretty good result. Once that is done, I deployed this on the video, and as you can see, it is able to do a pretty good job. I will start my kernel and we'll start importing Ultralytics, CV2 and other dependencies. This is the model I have trained on the 250 epochs, and it's pretty good for me. This is the video for testing. These are the some gimmicks of Python to detect it and see. So are you ready for the final results? Let's check it. Yeah, amazing, no? See, it is able to detect each and every fish, its movements, and it is able to track them, and it is able to see the following lines. So enjoy it for now. I can detect the fish, I can detect the speed of it, how much it is moving, where it is moving, and if it slows down, I can detect whether it's an eel fish or a dead fish. So hope you have enjoyed this video. Stay tuned for the next time. Bye bye.